All right, so let's go over these three proofs here. So this first one, we are given two segments and then we're trying to prove the whole triangle. So I'm going to label my segments, and then remember, it's always a good idea to first start with your given statements in your proof. So you always want to say what's given or say what's given and then move on. So KM is congruent to NM. So just label those, and I'm going to write that as well. So KM is congruent to NM. And my reason is that it is given. Okay. And then there's another segment given. So LK is congruent to Ln. So I'll write that as well. LK is congruent to Ln. And then it's given. So you always want to write, at least what you can on a proof. If you get stuck somewhere, at least you have something down. Say if it's a test question, you at least get, part of it. So now notice I have two sides. So now I have to think, well, what can I say about a third side? So is there a third side that I can prove? So if you see LM, notice how they share this side. Okay, they share that. So that means that it would be congruent. For example, if I split up those two triangles, they would have that exact same side length. It would be congruent. So I can now say that LM is congruent to LM. And what property tells me that a shared side is congruent to itself? That's the reflexive property. Okay, and so I was able to say that all three sides are congruent to each other. So now I can say that triangle LKM is congruent to triangle LNM, and that is via the side property. And that's it. Okay, so let's take a look at number 11 here and see what we have. So with number 11, I am going to first label some things and then do my given information. So I have been given that AD, and they also actually label this. So AD is congruent to AB. So I'm going to write that. AD is congruent to AB, and that was given to me. Okay, so now you have some options here for what you want to label. And with number 2, I'm going to put the other given part. So I'm going to say AC is congruent, or I'm sorry, whoops. AC bisects angle DAB. So that was given to me as well. So then if I go to my figure here and I want to note that on here, so AC bisects DAB. So it bisects this angle here, which means that these two angles are congruent. So now in my proof, I also want to state that angle, A is, angle DAC is congruent to angle BAC. Okay, so angle DAC is congruent to angle BAC. So DAC, so remember the vertex is in the middle, so that letter A, DAC, and then BAC. And then how do I know that? Because of the definition of angle bisector. Okay. So now what do we have? We've got a side, we've got an angle, so we need another side. We need this side here, which I can say now AC would be congruent to AC, just like in the last one. So AC is congruent to AC. And why is that? The reflexive property. Okay, so now you have a side, angle, side, and we can write our congruency statement for the triangle. And we can do that because of side, angle, side. So there's our completed proof. Okay, let's take a look at number 12, the last one. So we have, we're given that JM is congruent to MN. So I'll write that. JM is congruent to MN. All right, that's given to me. And then L is the midpoint of JN. That's given to me. So let's look at what that means on there. So if L is the midpoint of JN, so L is in the middle. So what does that mean for these two segments? This means that they're congruent to each other, right? So those are congruent to each other. So now what can I say then in my third line? I can say that JL is congruent to LN. So JL is congruent to LN. And that I know that because of what? The definition of midpoint. Okay, so now I have two sides. So can I get that third side? How could I say that this is congruent to itself? LM is congruent to LM because of why? The reflexive property. So LM is congruent to LM because of the reflexive property. And now I can say my congruency statement. And that is because of side, side, side. And that's it.